This tutorial is going to show you about exponential growth and decay. And yesterday you looked at exponential functions in general. So an exponential function is of the form y equals a times b to the x power. And we found out yesterday that this a value tells you your y-intercept, and this b value tells you the number that you multiply by y on each of your tables. When you fill out your table, whatever that b value is how you get from one y value to the next. So for instance, if this was 4 and this was 8, you're multiplying by 2, so your b value would be 2. Or for instance, in your table, if it was 9 and then 3, you're multiplying by 1/3, so your b value would be 1/3. So there's a few other things that have to hold true for an exponential function. The first is that a cannot equal 0. Because if a was 0, 0 times anything is 0, your equation would just be y equals 0, which we know is a horizontal line. That's not going to be exponential. So a can't be 0. B has to be positive, and that's because this value here, you have to have a positive number, otherwise you're going to skip back and forth between positives and negatives as you raise it to the power of x. And then also b cannot equal 1, because if b equaled 1, you would have y equals a times 1 to any power. Well, 1 to any power is just 1, so you would just have y equals a. That's, again, a horizontal line. Okay, so those always have to be true. But now let's get into what we're really looking at today, which is exponential growth and decay. When I'm talking about exponential growth, I'm looking at a function that when you graph it, it grows as you move from left to right. So we saw some functions that looked like this yesterday. So if it grows from left to right, those were specific functions where your b value was bigger than 1. Okay? Now the other thing that has to be true, and this is going to be true for both growth and decay, we want our a value to be positive. Okay, so we're looking at exponential growth here. Now, an exponential growth model exists in the real world, and it's a bit of a lengthy formula, but let's go ahead and write it down, and then I'll explain what each of these things mean. So y equals a times the quantity, in parentheses, 1 plus r to the t power. So what do all of these things mean? Well, first of all, this a right here, this is going to be your initial amount. This is your starting amount. Okay. R is going to be your rate. So this R value is your rate of change. But the important thing is you need to change that to a decimal. A lot of times it's going to be given to you as a percentage and you need to change it to a decimal. And as a reminder, to change from a percent to a decimal, for instance, if it's 25%, to change that to a decimal, you move that decimal 2 spots to the left. So 0.25 would be your decimal. If you had 2%, changing that, you move it 2 spots to the left, that would be 0.02. Okay, so this R is your rate that's given to you in, as a decimal, and then T is going to be your time, and typically we give that in years. What's time right now? So we're going to give that in years. So it's probably easiest to look at this with an example. It says you put $125 in a savings account that earns 2% interest, compounded or calculated yearly. So that word compounded just means how often are they calculating your interest. You do not make any deposits, meaning you don't put money in, and you do not make any withdrawals, meaning you do not take money out. How much money will you have in 30 years? So to set up this function, we're going to go ahead and write our equation. So y equals, this is our amount of money. The initial amount, well, we started with $125 times 1 plus, well, your rate, it's 2%. So we said 2%, we need to change to a decimal. So again, you move that decimal 2 spots to the left. So it's going to be 0.02. So 1 plus 0.02. And then after 30 years, that means our time is 30. So now we're going to use our calculator. The calculator should do 1 plus 0.02 first, because that's in the parentheses, then raise that to the 30th power, then times 125. So go ahead and type that in your calculator, and you should get a dollar amount. We always want to round to the nearest hundredth if we're talking about money. So this should be $226.42. So after 30 years, you have now $226.42 when you're earning 2% interest annually. Okay, so that's exponential growth because the amount is growing. But not everything grows in the real world. Sometimes we have decay. So that's a situation where when you go from left to right on your graph, it's going down. So this is exponential decay. Well, this happened when our b value is in between 0 and 1. Okay, so if you have a fraction, so something like y equals 2 times 1/2 to the x power, this 1/2 is what makes the graph go down from left to right. So that's decay. Again, your a value is going to be positive. Now, your decay model looks almost the exact same. A times 1. Now, instead of a plus sign, you're going to have a minus. So 1 minus r to the t power. So again, A is going to be your initial amount. R is going to be your interest rate or whatever the percentage is. But again, you want to change it to a decimal. And T is your time. So here we have a farmer bought a tractor in 1999 for $30,000. The value of the tractor has been decreasing at a rate of 18% per year. So that means since it's decreasing, that's how I know I'm talking about exponential decay. I want to know the approximate value for the tractor in 2005. So the amount that it's worth, here's our initial amount, 30,000, times 1 minus, now 18% as a decimal. We move that decimal over 2 spots, so it's 0.18. So it's going to be 1 minus 0.18 raised to the t power. Well, how much time is passing? From 1999 to 2005, that's going to be 6 years. So we're going to put a 6 there. Again, we type it in our calculator, and we should get $9,120.20. Make sure you get the same thing typing it in your calculator. Remember to follow order of operations, parentheses, then exponents, then multiply by the 30,000. So now I want you to try the rest of the problems on the back. Write down any questions if you have any, and we can go over those once I'm back.